okay, and that is the main characteristic property of alkanes. Substitution reactions are main properties. So, these reactions are beyond the scope. So, we are not going to discuss all these things. Classification is more important. Therefore, saturated hydrocarbons is first one that, and under the unsaturated hydrocarbons we have alkenes and alkynes, and I recollect we are studying only the hydrocarbons classification. That is why alkenes, these are the aliphatic hydrocarbons, they contain at least 2 such carbon atoms which are sp2 adjacent to each other. Means these sp2 hybridized, they will be having double bond. If you see propane 1 in here, the first carbon atom and this central carbon atom are sp2 hybridized, rest of this they are sp3. In ethine, in this propane should have come here. So, it is a structure here, and see here ethene is another example, CH2 double bond CH2, and propene, one propene which we can write here as this is first carbon atom sp2 hybridized, second carbon atom is sp2 hybridized, whereas the third one is sp3 hybridized. There is a adjacent carbon atom, these two have a double bond, one is sigma bond, another one is pi bond, and these two hydrogen atom attached to the first have the sigma bond between carbon and hydrogen, and again this is also a sigma bond, and these three have sigma bond. So, 3 plus 1 4 plus 5 6 plus 2 6 plus 2 is 8 and 1 pi bond, 8 sigma and 1 pi bond here in the propene. Like that you can count. There will be a questions how many number of sigma and pi bonds in a given molecule of alkene, they may ask. So, here there are 2 plus 2 4 plus 1 5 sigma bonds and 1 pi bond in case of ethene. So, you can make it up when you write the this is structure, this is condensed formula, and this is bond line diagram of the propene. So, you have to write only this type of structures. If you know this, you can also write this, but it is better to have this type of structures only, that is condensed formula. So, condensed formula of this. Next one is the unsaturated hydrocarbons are alkynes as well. There is another category, those aliphatic compounds which contain at least one carbon to carbon triple bond. That means 2 sp hybridized adjacent carbon atoms in a given chain, and rest of the carbon atoms are sp3 hybridized. These hydrocarbons can be represented by general formula CnH2n minus 2. Examples ethine. So, propine triple bond is here. So, there is a here H is not there. So, there is a mistake, one H has come here extra. So, you have 3 plus 1 4 5 6 sigma bonds, this is not there. So, then 2 pi bonds are there. So, alkynes and this is alkynes. Next, as you know, see this is we have completed saturated and unsaturated, alkenes and alkynes under unsaturated, saturated alkenes. So, now we will go to cyclic or closed chain hydrocarbons. So, carbocyclic compounds, they are nothing but closed chain organic compounds. A large number of organic compounds possess ring consisting of carbon atoms only. Such organic compounds are called carbocyclic compounds. These can be further classified as explained below. They are alicyclic compounds, there is a cycle, complete cycle, and their properties are more or resembles like aliphatic hydrocarbons, and therefore, their names start with cyclo, ends with alkane names. So, therefore, there are so many examples, you can just quote it. So, here is cyclopropane, cyclobutane, cyclopentane, cyclohexane. So, this is misplaced, it must have come here. So, that has gone there. So, these are unsaturated, even in the unsaturated. So, it is correct as well. Cyclopenta 1,3 diene means 2 double bond, there will be unsaturated as well here. These are all saturated hydrocarbons, carbon atoms sorry, and therefore, but they have ring structure, look at that ring structure, and hence the name alicyclic, cyclic means closed chain structure, and their properties they undergo substitution reaction. Okay. If they have double bond, then they undergo even addition reaction as well. So, that is the reason why they are showing showing the alkane properties. Next, aromatic compounds. As I already told you, aromatic compounds are those which have ring structure, which rings resembles like a benzene, and they fit into the Huckel's rule. That rule is not important for us right now, we are interested in classifying. So, aromatic compounds can be classified into two broad categories, having a benzene ring structure are said to have benzenoid aromatic compounds. If not, they are called as non-benzenoid carbon atom. So, non-benzenoid hydrocarbons. Here benzene is the best example, naphthalene is another benzene structures you have fused together. Then we have aromatic compounds which do not have benzenoid structures are called non-benzenoid aromatic compounds. So, cyclopenta 2,4 dienyl cation, this is a best example of example of aromatic. This is a aromatic compound, it fits into the Huckel rule. However, this has no benzenoid structure, it is other than that. So, like this one or two examples you got to remember, that is all. So, what are heterocyclic compounds? Organic compounds containing ring composed of carbon and a foreign element as well. Look at this, here we have 5 membered ring. So, 1, 2, 3, 4 carbon atoms and oxygen as one of the member of the ring. So, this is having a double bond as well, and this is furan. Furan is a molecule and which is a heterocyclic compound. Pyridine is one more example in which there are 5 carbon atoms and 1 nitrogen are the member of the ring, and this is a hetero atom, and hence this molecule is heterocyclic molecule, and compound is pyridine is another example. So, organic compound containing ring composed of carbon and a foreign element, that is other than carbon such as nitrogen, oxygen, sulfur may be member of the ring, not as a substituent to the benzene ring, but they must be member of the ring. So, then only they are called as heterocyclic compounds, right. So, this is how we can classify the aromatic compounds and heterocyclic compounds. So, this is about the classification of organic compound based on their structures, and we took the classification of hydrocarbons here, hydrocarbons. Now, we can classify the organic compounds even based on the functional groups as well. What is a functional group? So, functional group may be defined as an atom, it may be a single atom or it may be a group of atoms joined in a specific manner, which is responsible for characteristic chemical properties of organic compound. Suppose if you take one functional group, see here, if we take ethane and replace one hydrogen of ethane by bromine atom, then it is substituent which comes into the ethyl moiety, and it gives a set of properties to this molecule, and hence here bromine is a functional group. It will induce certain set of specific properties to this organic moiety, and therefore, it is a functional group. Similarly, if one hydrogen of methane is replaced by hydroxyl group OH group, then the entire molecule have certain special set of properties, and that is due to the presence of OH group. So, therefore, this OH group is inducing certain or makes it is attached to this carbon atom in a more specific manner, and induces this molecule to behave in a particular way with respect to their chemical properties, and that is why such group of either atom or a group of atoms which will induce or give a particular set of characteristic properties to the molecule, they are called as functional groups. So, based on the functional group we have hydroxyl functional group which will induce certain set of properties. We have aldehydic group CHO and carboxylic group, that is COOH group, etc. Organic compound can further be classified into various groups, functional groups based on functional groups and what they possess. If they have functional group, we can classify them that. So, we were supposed to consider the classification of organic compound based on the functional groups. So, classification organic compounds, again these are open chain, closed chain, and in this I can call it as halogen derivatives, aliphatic alcohols, ethers, aldehydes, ketones, acids, amines, there are huge. So, what type of atoms or a group of atom can give a set of chemical properties so as to call them as alcohols, that is OH group are directly attached to the either sp2 hybridized or sp3 hybridized carbon atoms. So, like that we can have the functional groups. Based on functional group, all aliphatic and aromatic hydrocarbons can have different groups. They may be alcohols, there may be esters, there may be ethers, ketones, acids, there may be amides, etc. So, I am just taking the example side by side. Say one side I am taking of aliphatic hydrocarbons and examples, and these are the functional groups, and these are the homocyclic or alicyclic hydrocarbons and their derivatives with the functional groups, and carbocyclic aromatic, the aromatic examples are here. So, simultaneously we are seeing all the examples here. So, first of all we take halogen derivatives. Here R is alkyl group or aryl group, let us say alkyl or aryl, I should have written aryl as well here, but X is defined as any halogen atom. So, any one halogen, this is a functional group, here halogen derivatives. So, aliphatic halogen derivative open chain structures, for example, bromoethane. So, there are 2 carbon atoms, therefore, it is ethane, and we have cyclic. So, chlorocyclohexane, this is chlorobenzene. So, benzene is, this chlorine atom is not part of the aromatic ring, it is not a part of the aromatic ring, it is side attached to the sp2 hybridized carbon atom here, this is sp3 hybridized, here it is sp3 hybridized carbon atoms. So, then we can have chloro, fluoro, etc. there, we have taken bromo here, chloro here and some compounds. So, most commonly available compounds I am writing the example. Alcohols, we have OH group attached to the either aliphatic or aromatic moiety. So, cyclopropanol, phenyl methanol is a example, and here aliphatic hydrocarbon methanol, ethanol, etc. So, ethers, they have the functional group O, and here it may be alkyl or aromatic aryl or one alkyl one aryl, like that. Here there is a methyl group and here is a methyl group, these together will make a ether. So, methoxyethane, cyclopropyl methyl ether and methoxybenzene are the examples for aromatic, for alicyclic, and these are aliphatic. So, there will be, I am giving you just a brief idea and you are supposed to know 1 or 2 examples from each. So, there is not much required from the point of view of examination. So, aldehydes we have aldehydes, functional group is CHO. So, methanol, ethanol, CH3CHO, methanol, CH3H, and cyclopropane carbaldehyde, benzaldehyde are the examples of alicyclic and aromatic aldehydes. So, ketones C double bond O, therefore, we have propanone, acetone is the best example for aliphatic hydrocarbons, their derivatives of ketones, and alicyclic you have 1 cyclopropyl ethanone and 1 phenyl ethanone. These are the example for alicyclic and aromatic hydrocarbons, aromatic ketones. Carboxylic acids, methanoic acid, formic acid it is, ethanoic acid what we call it as vinegar, and CH3COOH that is acetic acid, methanoic acid HCOOH, functional group HCOOH acid, these are all acidic compounds, and the one alicyclic compound I have cyclohexane carboxylic acid, cyclohexane carboxylic acid, and benzoic acid is another example for aromatic acids, right. So, we can have metal carboxylates. So, we have sodium ethanoate or sodium acetate we call it as commonly, and this we have sodium cyclobutane carboxylate, then sodium benzoate are the examples. Esters have the functional group COOH, methyl ethanoate. So, and these are the examples of methyl cyclopropane carboxylate and methyl benzoate are the examples of esters for aromatic and alicyclic. So, methyl ethanoate is for aliphatic hydrocarbons. So, acyl group is COCl. Here chlorides are more stable, that is why acetyl chloride is example for aliphatic, whereas cyclopropane cyclopropane carbyl chloride is example for alicyclic and benzyl chloride for aromatic. So, like that, and amines are the compounds which have NH2 group and amides have CONH2 group. Aminomethane example cyclobutane amine, aniline are example for aromatic, and this is for alicyclic and this is for aliphatic. Okay. So, these are the examples, and there are some books. So, I would like to take the last I mean glass loss, there was some mistake there on slide number 7, and you should please read this as there was a division there m by g, but it is m multiplied by g. So, then there is a year mentioned, you read as it was written there. So, these are the corrections. Inconvenience is highly regretted. So, this was the lecture on gas loss. So, then the further information you can write to me, and I take this opportunity wish you happy Deepavali as well. Thank you very much.